In today's video, we'll explore the nth term test, which helps determine whether a given infinite series diverges. If the limit of f sub n as n approaches infinity is not equal to 0, then the infinite series a sub n diverges. It is crucial to note that this test does not provide information about convergence. Now, let's delve into the proof of the nth term test. To begin, we'll establish the statement: if the sum of a sub n as n goes from 1 to infinity converges, then the limit of a sub n as n goes to infinity is 0. We'll first prove this statement and then utilize the contrapositive to demonstrate the nth term test. Here, we have an infinite series represented by a sub k, where k ranges from 1 to infinity. Expressing this infinite sum using a limit as n tends to infinity, we can write it as the limit of the sum of a sub k as k goes from 1 to n. Rewriting this expression with the limit applied to the finite sum, we get the limit of s sub n as n approaches infinity. Assuming that this infinite sum converges, we can denote its value as an arbitrary constant, let's say L. If you list the finite sum, it can be expressed as the limit a1 plus a2 plus a3 plus all the way down to an minus 1 plus an. Simplifying the sum of a1 to an minus 1 as a sub n minus 1, the expression becomes the limit a sub n minus 1 plus a sub n. So the left side was originally the limit of s sub n, and expanding the right side as a limit expression gives us the limit of s sub n minus 1 plus limit of a sub n. Since we assume that the infinite sum converges to L, the left side becomes L, and the right side becomes L plus limit of a sub n. In the end, we obtain the result that the limit of a sub n as n approaches infinity is 0. What we have just proven is this: if the sum of a sub n as n goes from 1 to infinity converges, then the limit of a sub n as n approaches to infinity is 0. However, what we want to know is whether a given infinite series diverges or not. And this statement provides information in the opposite direction, saying if some infinite series converges. Therefore, we still cannot use this to determine whether a specific infinite series diverges. Now, let's try to rephrase this expression into something more meaningful for us. To do that, let's briefly look at what contrapositive means. If there's an expression, if A then B, its contrapositive is if not B then not A, and this is always true. By swapping A and B and adding not to both A and B, we can create the contrapositive. For example, looking at the expression, humans are animals, we know that this is true, and its converse, animals are humans, is not always true, as zebras cannot become humans. However, the contrapositive, if not animals, then not humans, is always true. In other words, if something is not an animal, it cannot be a human. This logical principle is frequently employed in mathematical fields and plays a crucial role in logical reasoning and proofs. So we want to create a contrapositive equivalent to the result we have proven earlier and use it. The contrapositive of our earlier proven statement: if the sum of a sub n as n goes from 1 to infinity converges, then the limit of a sub n as n approaches infinity is 0, is if the limit of a sub n as n approaches to infinity is not 0, then the sum of a sub n as n goes from 1 to infinity diverges. Now, with this result, let's determine whether the given infinite series diverges or not. Keep in mind that the nth term test is a test for divergence and does not provide information about convergence. Let's consider the first example, the sum of n plus 1 over 2n minus 1 as n goes from 1 to infinity. We'll change the sigma notation with a limit. So we have the limit of n plus 1 over 2n minus 1 as n approaches infinity. To evaluate this limit, we multiply both the numerator and denominator by 1 over n. This leads us to the limit of 1 plus 1 over n over 2 minus 1 over n. And as n approaches to infinity, the 1 over n terms in the numerator and denominator becomes negligible. Therefore, the limit is half. In summary, the limit of n plus 1 over 2n minus 1 is half, which is not equal to 0. As a result, by the nth term test, the infinite sum of n plus 1 over 2n minus 1 diverges. The second example is the sum of 3 to the power of n over n to the power of 3 as n goes from 1 to infinity, and we'll convert this sigma notation to a limit to apply the nth term test. Thus, we have the limit of 3 to the power of n over n to the power of 3 as n approaches infinity. The value of this limit may not be immediately apparent, but since it takes the form infinity over infinity, we can apply L'Hopital's rule. I will cover more details about L'Hopital's rule in another video. Using L'Hopital's rule, by differentiating the numerator and denominator, we get the limit of 3 to the power of n times ln 3 over 3 times n squared. Again, as n approaches infinity, this expression evaluates to infinity over infinity, allowing us to apply L'Hopital's rule once more. This leads to the limit of 3 to the power of n times ln 3 squared over 6n. And once again, as n goes to infinity, the result is infinity over infinity, prompting other application of L'Hopital's rule. Now, we have the limit of 3 to the power of n times ln 3 cubed over 6. And as n approaches infinity, this limit becomes infinity. In other words, it's not 0. By the nth term test, since the limit is not 0, the sum of 3 to the power of n over n cubed diverges. This example is a straightforward one. It's the sum of arctangent n as n goes from 1 to infinity. Again, to apply the nth term test, I will replace the sigma with a limit, resulting in the limit of arctangent n as n tends to infinity. What is the value of this limit? When does tangent x diverge to infinity? It happens at the vertical asymptote, which is at pi over 2. Therefore, the limit is pi over 2, and once again, this value is not 0. Since a non-zero result is obtained, the infinite sum of arctangent n diverges. Finally, let's delve into the last example. To determine the divergence of the infinite sum of 5n squared over 3n cubed plus 1, I will replace sigma with a limit and examine this limit. The limit of 5n squared over 3n cubed plus 1 as n approaches infinity, after multiplying both the numerator and denominator by 1 over n cubed, becomes the limit of 5 over n over 3 plus 1 over n to the power of 3. As n tends to infinity, both the 5 over n in the numerator and the 1 over n cubed in the denominator go to 0. Ultimately, this limit becomes the limit of 0 over 3, resulting in a value of 0. Now, does this infinite series diverge or converge? The answer is we cannot determine it. The nth term test only allows us to check for divergence, meaning we can conclude it diverges only when the limit is not 0. If it is 0, other tests need to be employed. There are various convergence-divergence tests, and it can be challenging to know which method to use when. I will strive to explain them in a simple and detailed manner through future videos for your better understanding. Please watch and support. Lastly, let me emphasize this once again. The nth term test learned today cannot determine convergence. Please keep that in mind. If you enjoyed today's video, please like and subscribe. Thanks for watching, and until next time, I've been your math guardian, Alex.